Hello, Dr. Eaglin here again with Module 12, Lecture 1 of EGN3613 Engineering Economics. And I know at this point you're probably saying there can't be any more ways to evaluate financially projects. We've looked at present worth comparative analysis. We've looked at annualized. I looked at the whole thing annualized. We've looked at rate of return, which looks at the interest, the I. Solve for I in this case, percentage rate of return. And you're thinking, God, there can't be another way to do this. But guess what? You'd be wrong. Yes, there is. Benefit cost analysis. So let's look at that. You need to know them all. Okay? You should be able to list them off. Compare the present worth. Compare the annualized equivalents. Compare the rate of return. Oh, I like to say solve for I. And now a fourth one, benefit cost analysis. Now, when do we use benefit cost analysis? Well, we typically use these on public projects. And the reason is it's really good in handling some of the different pieces of the project that might be non-monetary in nature. However, they do need to have some sort of monetary equivalent for you to be able to analyze them. So, you've got users and you got sponsors, the people that are going to benefit from the project, the people that are going to put forward the money. For a government public project, sponsor would be the government, but the users are often, okay, good old public, you and me. What kind of projects are you talking about? Bridges, waterworks, dams, all these things that, you know what? Probably good projects. So, owned by the citizens or the public, on fairly common types of projects you're looking at that will be done with the benefit cost analysis. Okay, probably will not be a profit portion of the project, even though that doesn't mean that there won't be. But there's a lot of things that you want that just may not, that you need, may not just come out going financially, this is the way to go. Hospitals, parks. I like parks. Parks are a good thing. Schools. Schools are also a good thing. Now, some characteristics of these projects. Usually they're pretty big. You know, you're talking big money. They last a long time. 30 to 50 years, hundreds of years, whatever. The cash flow, there will be benefits. The benefits can be put in terms of dollars, but might not be any profit. Now, some of the projects may have pros and cons. Controversial projects that have, just like, oh, we're going to put it in an interstate. But that's a positive project. Well, it might not be a positive project if it's going through a nature preserve. Okay, it's a negative, there's a positive, both. So how do we look at this way, cost-benefit analysis, sometimes called benefit cost analysis, of evaluating these projects? Well, there's a way to do that. First, let's figure out how long this project is going to last. And could potentially be, essentially infinity as far as we're concerned, because once you get above a certain value, it's really hard to actually show what the benefit, the costs go way out into the future, but the benefits go way out in the futures too. So you'll have an initial cost. That's going to be the cost of building it, putting it together. You're probably going to have a cost of an annual cost, okay? Probably things like maintenance and operations. You need to know who the stakeholders are, the users and the sponsors, and you need to be able to write down the benefits and what we call the disbenefits, those things that are not benefits but the exact opposite of the project. And you need to quantify those things. Now, hopefully, you can quantify those things in dollars, because dollars is the way we typically go. And you also need to have an interest rate that we can use for discounting the benefits and costs, because we need to put everything in equal monetary footing, and they might not all occur at the same point in time. So you will need an interest rate that's associated with that. So then once we've got all these things written down, identified, we know what they are, we can now say, okay, what is the benefits to cost ratio? Well, it's the present worth of the benefits over the present worth of the costs. Well, we can also use AW, annualized. We can also use FW, future, because reality is, it doesn't matter. They should all come out the same. Present's probably the way we're going to go. So let's look at the criteria, benefit to cost ratio. So the benefits typically are benefits to the users. Costs, typically costs to the sponsor. You want this to be bigger than 1. You want to get more benefit to the users than there is cost to the sponsor. And what I mean by cost to the sponsor, well, that'd be cost to the government. Government may get benefit, but the government's probably going to be doing most of its projects for the benefit of the users, which are essentially the citizens of the government. When you build an interstate, yes, the government does get a benefit from that interstate or road or bridge, but the users are the ones that truly get the benefit. Now, when this great super equation right here is essentially saying, what is the benefit? What's the sum of all the benefits? And what are the costs? The sum of all the costs. Remember, the benefits and costs can occur at different points in time. So as you can see, they are adjusted for the interest rate over time. And in this case, they're put together as a present worth, as a PW. You bring them all to the same point in time. And you just basically sum up all the benefits and all the costs over the project life, adjust them to the same time frame, and you've got it. Now, we do want to take into account that there are different types of costs. One of the costs is going to be capital investment. That's money put directly into making or building or whatever. Operations and maintenance, O&M, is another cost. Okay. Now, the capital investments may occur prior to time zero, where the O&M costs will pretty much always occur after time zero, but they all come back to time zero. So the BC of I, the benefit to cost ratio, is just the B over C, but which is really the B over I plus C prime, because where the I plus C prime is really the actual cost of the two components associated with the project. So put this together, really not that hard. This one, you got some costs, you got some benefits. One of the costs is investment. The other cost is recurring cost, probably maintenance. The other benefit is benefit. It's a 5-year project in this case. Okay, well, what do we do here? Straightforward. Put them all present. Okay, if it's an annualized, put it to present. Put them all together. Okay, B over I plus C prime. You can tell you got the 3 different types of costs that were actually denoted in different colors. And if it is greater than 1, the BC, at a specific rate of interest, okay, is greater than 1, it's an acceptable cost. Now, how does this all come together? Well, net present worth really is just kind of a way of saying B minus C is greater than 0. That's it. That's not much. Now, remember that last week that or the last module where I talked about incremental analysis for evaluation of projects, where you subtracted the cost of one project from the cost of the other, the benefit of one project from the other, and then you looked at that and compared it to the MAR. Hey, guess what? It works perfectly well for benefit cost. You can use the same process. Look at the deltas. And then when you look at the deltas, okay, it's a delta of a project versus another project. So if you break the projects down into I, B, and C prime, those are the 3 variables we had in that last set of equations. Okay, the benefits, the investment cost, the recurring costs, or maintenance, O&M costs. Then get them all down onto a table, and then looking at that table. Now, in this case, the present worth should be easy to figure out because it's simply B minus I minus C prime. So that first one, 12,000 minus 5,000 minus 4,000 is 3,000. Okay, so those numbers should not be any great mystery, and it's also not high-end math. But if you look at a comparative analysis of one versus the other, okay, which should basically be delta I over the delta C and the delta B over the delta I plus the delta C prime. If that is greater than 1, that means that project is going to be a better project than one that you're evaluating it against. And just like in incremental analysis, if we had more than one project to look at, we simply compared 2 of them, picked up the better one, compared to the other one, picked up the better one. Okay. If it's not the better one, the deltas, delta B over delta I plus delta C prime, is not going to be greater than 1. If it is, it will. See, not that challenging then. Remember, this is how you do it. All right, so big summary. Okay, big public projects. You do need to identify the users and identify the sponsors. Usually the sponsor is going to identify the users because the sponsor is the one trying to do it. Identify benefits and disbenefits, and disbenefits are not costs. They're disbenefits. Things that are bad about the project. Quantify them, hopefully into dollars. Select an interest rate at which to use for discounting to a present value. And there you go. That's pretty much it. There's the equation, and you got a nice easy decision. Is BC of I greater than 1? Is it a good project? Okay, that wasn't that bad. It really wasn't. Cost benefit. And we're getting near the end. That was module 12. I only have 2 modules to go. However, everybody needs to go back and make sure they are comfortable with time value of money, all the different ways of looking at money, adjusting for 2 big things right here. Well, actually 3 big things: interest, compounding, and payment schedule. Those 3 things do happen. And then looking at the different ways that we can compare projects. And this is number 4 of those. Thank you much. We're moving along. We're almost there, people. We're almost there. As you can see, though, I've been grading homework, so I know how challenging this stuff can be. On out.